Hello, everyone. I hope you're all having fun this year on AmigaOS. People from your home and everywhere you are. I'd like to thank AmigaOS for having me, for hosting this presentation. And I'm here to talk to you about cross development for Amiga and continuous integration and continuous deployment using Docker. My name is George Sokianos. You can find me as a Volcano in different forums. Let me start my presentation by an introduction about me. I'm a software engineer. I'm Greek, and the last 2 years I live in Dublin, Ireland. I'm a beta tester for AmigaOS 4, AmigaOS 3, and X1000, X5000, and the latest Tabor A1222 from Aeon. And also, I'm a beta tester for the enhancer package that AmigaKit is deploying. Also, I'm a system administrator and developer on different websites related to Amiga and different applications running on Amiga or help on Amiga development, which we might see in the future. What I'm going to talk to you about is Docker and how we can use it on development, cross development for the Amiga, and what are the benefits of using Docker for this process. We will see how to set up a VBCC and GCC for Amiga development on our system. How we can use Docker with the VS Code IDE, and also how we can introduce continuous integration and continuous delivery in our process using Docker always. So, first of all, what Docker is? Docker is an open platform for developing, shipping, and running applications. It is used broadly right now for from a lot of companies, and the benefits are a lot. And using Docker, you can make production and deploying of your applications much faster on an isolated environment, which you can be sure that your application is going to work as it was working on development process. Parts of Docker are if you are not familiar with Docker, have that in mind like a virtual machine. So a virtual machine has different parts. Docker uses images as the hard disk, let's say, of the uh, virtual machine with the operating system and all the necessary applications already installed in there. Containers are the actual machine, the actual virtual machine that uses parts of this of the image to run the software, and also maybe it uses parts of the host machine to communicate with the host machine, like the network connection. Networks are a part of the Docker infrastructure that has to do with how the containers communicate with each other and how they communicate with the outside world. And volumes are the mounted, let's say, partitions or hard disks that you can share from the host machine and the container itself, so that you can exchange parts of code or software, etc. The benefits of using Docker in development are a lot, and here I have a list of a few of them. Uh, First of all, it is easy and really fast to set it up on your machine. Uh, we will see the process later on demo, and this can be done from the experience of setting this up on any machine. It's the same, uh, dep not depending on the operating system. It is a standardized development environment. So if you are working on a team and everyone is using uh, Docker, then everyone is having the same development environment with exactly the same software. Uh, it supports all major operating systems, and it works just fine on Linux, on macOS, on Windows. So you can use it on any operating system that you want. You can use also any tool you like for development. You are not restricted by the operating system or the environment that someone built for you. That's how you can use any version control system that you would like to support for your project, or any IDE that you would like to use. The development environment is isolated by the host machine and the other development environment that you might have. So you cannot harm other installations. Let's say if you would like to have a VBCC installation and a GCC installation on the same machine, or if you would like to have different VBCC installations for different CPUs, everything can be isolated, and this cannot break the other installation. You can have multiple compilers on the same machine, so with no extra hassle on bringing them on your machine, because everything is isolated on its own, let's say, virtual machine somehow. It also, Docker has a small footprint, which means that it is not so huge to install something on your machine. And even if you make changes, these changes are stored in a way that only the differences based on this on the source image are stored on your machine, and not uh, different versions of the same thing. For example, if you have a virtual machine, an actual virtual machine using VirtualBox or something like that, if you want to have the same virtual machine but with a different installation, you actually copy the hard disk of the virtual machine and create a separated second hard disk, and where you make your changes. With Docker, you can have the base installation, and above that, you can make only the changes for, let's say, VBCC for 68K CPU, or the changes for VBCC for the PPC CPU. So the base installation is only once written or stored in your computer, and the rest of the changes are separated, stored on your computer. So you don't have two times the same thing stored on your hard disk. Code can be shared between the host machine and the Docker containers, and you can access them from both sides. Docker can be used as well on continuous integration, continuous deployment processes, uh, just like Jenkins or Circle CI or Drone CI. You can also have a version control of the implementations of your Docker images, since these are actually code that is executed when you build a new image. So if you would like to have different versions of these images, you can store them in uh, your GitHub or somewhere like that. And if something breaks on the newest version, you can always roll back to the previous version and use it as well. The Docker images are expandable, so you can get something that someone else built and build your own solution on top of that. And also, Docker has a big community of developers, which is always helpful for finding the best solutions and help from other people. And also, you not always have to build everything from scratch, but take something that is out there and make your changes and build your own solution that works for you fine and the way that you would like to work. Currently, if we don't use Docker, if we would like to set up a GCC on our systems, someone should follow a big guide on how to do it on their system, which many times is complicated, and some people don't. It's not easy for them to follow guides, and maybe 3 or 4 or 6 months later, this guide is already obsolete. So right now we have a very good guide in various websites that show how to create a cross compiler with for GCC 8.3 and how to do it on Windows, which is here on the images. You can see the number of pages that this guide is, which is more than 6 pages, and that's it. Actually, these the problem with these guides, uh, even if they are excellent and if they work, the problem is that this guide is only for Windows, and using techniques for that to work. So if someone wants to do it on macOS, he should find another guide to do it. And this is only for GCC 8. So have in mind that if you have to do it for different machines on your house, you have to follow this guide all the time. And you have to, in case that something breaks or in case that you have a small difference on your installation, this guide might not work. Let's see how we can do it with Docker and how easy it is to install to create your course compiler development environment on your machine. First of all, you have to install Docker on your operating system. This is a URL that someone can use, and this URL has the installation process of the Docker on their machine. Usually for Windows and for Mac OS, it's an installation package, an MSI or a DMG file that you have to download and install on your machine. Or for Linux, usually it is on the repositories. So an apt-get install or yum install or something like that, it's pretty fine to have Docker installed on your machine. The process is pretty simple as it follows the same process as most of the software that we install on this operating system. And as soon as we install that on our machine, let's see how we can bring VBCC for AmigaOS 4 or for the rest of CPUs and operating systems for our system. In case you want to install VBCC for AmigaOS, the only thing that you have to do is to run this line on your terminal. What it does is requires the Docker service to run a new container, which is going to be named as vbcc-ppc, and it's going to have a volume between the host machine and the container. From this folder that we are right now and the folder code inside the container, it's going to be in this path. And this container is going to, this is the working dir that we are going to use. This is the directory that we are going to be when we are going to log in inside the container. And this is the image that is going to be downloaded and installed in our machine that has all the software ready for us to use. And that's the command that is going to be executed as soon as we start that container, which means that As soon as we create and start that container, the bash command is going to be executed, and we are going to have access inside the container on terminal. We are going to see that exactly on demo later. That's the same command that we are going to do for the AmigaOS 3 and 68K CPUs. You will see that the only thing that changed is the name that we use and the version or the tag, if you like, of the same image. So you can have different images tagged with a specific version or a name, whatever you like when you build your images, under the same name of the image. And actually, we run again a bash to have access to the terminal. The same is happening for the MorphOS. These images, as you can see, are created by me, and those images have the VBCC installed and configured, and it's ready to be used, and also have different SDKs installed. For example, for AmigaOS 4, we have the OS 4 SDK installed, the new SDK installed for version 5, and also the Roadshow SDK install. It is installed in AmigaOS 3. AmiSSL is installed for all of them, and you have already packets to create applications out of the box. Of course, there is a way to add your own SDKs if you would like, or extend the SDKs that are already there. Those SDKs can be seen in my GitHub for Docker for Amiga VBCC, the same that we saw here. You can find a list of the applications that are already installed in different images and the versions, and also how you can use it, and what are the different environment variables that are already configured in this container. But let's see how we can install GCC. The same thing for GCC, only that we have different images here. One that is named Odyssey on Docker. The name came from my target for this image was to make Odyssey browser be able to get compiled in that image. And that's why it was named like that, which it does. And that was my goal for this image. But since this has the GCC 8.4 already configured there, you can use it as for any project that you would like to do it. This can be found as well in my repository. Odyssey on Docker. And exactly what packages there are already installed. For example, the SDL2 SDK and the SDL SDK are already installed there. And if you want to see exactly what is going on when someone builds that image, when I build that image, this Docker file has all the information and all the software that is installed. Actually, it is a bash script that downloads and installs the SDKs and all the necessary configuration for the GCC inside an image. And that's how you can create your own images or extend these images if you want. So everything, as you can see, it's open source. It's out there and everyone can use it. The same happens with GCC for Arrow that uses this specific image. this image is able to compile ARS itself and also Apollo OS for x68K, which also can you find in my repository. Demo time. Let's see how we install VBCC and GCC compilers for applications development for AmigaOS 3. Let's go back to this and copy and paste it into our terminal here. I have a terminal folder named AmiWest where I have a folder code, and in there you will see some demo codes that we can try to compile. So if I do that, already I'm inside this container because I already have the image downloaded on my machine. So if I do su amidev, this is a user inside the image that has the same permissions like the user we have in the host machine. This helps so that if we create any code or files, have the same permissions with the user that we have on the host machine, and they can both write, delete, and change files. So if we go to our PPC, and we see the code here, and let's go into the window. This code, this C code is already on the my repository, and they are demo code that you can try to combine. And if we do here a cat of window, you can see the code. And at the top of each code, I have the command that we have to run to compile it. So we compile here for our PPC, which is the PPC version of the VBCC, and also we include the SDK from OS4. If we see, the code is already compiled. And if we want to get out of this container, we have to use exit, and the second time exit, and we are off. The same happens if we do for the 68K, only that this time I don't have the image locally, so Docker tries to download. You will see that some parts of this image are already existing because they exist from the VPCC for OS4 image. That means that they share a page, so the Docker doesn't download again the same thing. The new image is already there, and we are already inside the container. Again, if we change the user, and if we see the code in let's see, let's use the make file, which combines the open win.c. We will see that already compiled. So you can use make files as well, and anything you need. And whenever you exit, these containers are deleted. But because of the, if you remember, here we have a volume where we share a folder inside our host machine with a folder inside the container. Because of that, our code is remaining inside our host machine, so it is not deleted, even if we do code and if we do a less here, we will see that the file that we compiled is already there, and it remains in the host machine for us to use it if we want. There is another way to, if you don't want to write all this big line of commands every time you want to do something, there's another way to create your containers and have a much more simple way to start these containers without setting all the time the same thing. This is using Docker Compose, which is a command that you can install along with Docker. Actually, it's a command that has some parameters and helps you to do different things. And it uses also for with the use of a file, a YAML file called Docker Compose. In that file, you can set what kind of containers you want to use, what images are they going to use, what volumes are going to be used between the host and the container. And that's how we set it. We create here the services. The services are the different containers, the names, the names of the each container, which image they are going to use. You will see here that they are the same images that we used previously, and what volumes they are going to use, which is the same code folder inside the folder that we are right now, and the opt code folder inside the container. Let's see a demo for that. First of all, let's see the Docker Compose YAML file that I use. It's a VBCC. It has a VBCC for 68K and PPC and Morpho with the latest versions of the containers of the images that I like to use and I created. And also each container has a volume, the same volume on the same code folder inside my current folder. And also it has a volume from my host machine SSH folder inside this user SSH, the AmiDev user SSH folder inside the container. I do that because I'd like to share my same SSH keys that I use in my GitHub account so that I can use the git command to get and push changes into the container. To start those containers, first of all, you have to do a Docker Compose app.d. This command takes that file, Docker Compose YAML file, and checks for differences and creates those containers. Right now, the containers are already created. And if I do a Docker Compose PS, it will show if those containers are running here. If it is up, this means that they run, and the names of each container. So right now, if I would like to go inside the container, I will do Docker Compose execute, which container, let's say this one, and what to execute? Bash. So right now you will see that I am inside the container, and I could change to AmiDev, to the code. Oh no, I'm already in the code. But if I do ls, you will see some projects that I have here. So right now these containers are still running on my machine. I prefer this way because I can use an IDE to connect with these containers and work on them, or put a work to be done in that in some of these containers. You will see that they still run, But if I would like to stop them, I write Docker Compose stop. You will see that they are already stopped. They do not run, so they don't get any resources from my host machine. And if I would like to start them again, Docker Compose start. So you see, Docker Compose makes things more simple because you write only one YAML file that has all the definitions for the containers already there, and you only need to a couple of commands to memorize that are pretty simple to remember. So since we now have the development environments already created in our machine, you saw how it is how easy it is to do it. Uh, we can use any tool we like to uh, use on our development process. For example, you can use any version control system like HVN or Git, whatever you want. Actually, both are already installed in these images, so you can use them outside of the containers on your host machine if you want, or inside the containers if you want. So if you use those containers, you don't need actually to install Git on your host machine. So you don't need to go on your Windows machine and install Git, install whatever you need. All these are already there inside the containers, and you can use them as well. So if you move from one machine to the other, you just download those containers, you start them, and you have everything already there. You can use any editor or ID you want, like VS Code or Notepad++, and you can use AmigaOS, one of my applications that can help you to uh, read the Autodoc files. We will see that in a few minutes. So let me show you that's something that we already saw. Yeah, we saw that. So let me show you how I use VS Code with the Docker container. Actually, I usually use a couple of extensions that are pretty useful, like the remote containers by the Microsoft, created by Microsoft, and this gives you the ability to connect inside a container. Let me show you here on my VS Code. I have the extension remote container. This gives you the ability to connect inside the container and do all your job there. This is useful because if you are connected inside the container, you can use extensions like C and C++ that it has intelligence, debugging, and you can have connections between your code and the actual libraries code, and you can see uh, and you can travel from one code to the other on your includes or things like that. And also I use Amiga assembly, which is created by Ranger. And for this extension, I am still investigating how I can use it because it can give you the ability to actually debug your code, but it uses, if I'm not wrong, a specific version of WinUI to do it because it uses some features of WinUI to debug your code. I'm still investigating that, but have in mind that it is there and someone might have better luck than me. Also, I'm using GitLens and Git history. Those are useful extensions for VS Code to manipulate your Git code and see the branches or the history of the code from different people and see when something changed and things like that. VS Code has Git integration from the first installation, but I find these two extensions really useful. And if someone learns how to use it, it is pretty powerful. You can, with GitLens, you can even see a difference between a commit and different commits, two different commits, which is pretty awesome. And also, I'm using Task Runner. This is an extension that gives you the ability to create tasks that you can run with a single click on list. This is useful for me because I have the tasks that I do most of the times, like build for specific CPU, my code using DBCC, and everything can be done with a single click. We will see that in a few minutes in the demo. Actually, the demo is right now. So let's see how I like to implement stuff on iGame. I don't know if you are familiar with iGame. It's a front-end application for 68K machines, and this is front-end for WSD load games. This was created by Mr. Zamler a long time ago, and the last 4 years it is open source, and I'm contributing with some code on that. So if I would like to do some work for the 68K code, I would like to go with the remote containers and attach to a running container. Remember that we have the containers running from here. We started them, so they still run. So if I go from this button right here and click, I can attach to the running containers, and I can choose which container I would like to use. I will choose the one that has the DBCC for 68K CPUs. And right now, it installs all the extensions that I need inside that container. You will see here. The local installed are the host machine, and the container installation are the extensions installed inside the container. Also, while it does that, if I go on the terminal, let's give it some time to do it. The reason that it installs all these extensions is because I didn't have, if you remember, I didn't have this image already on my computer, and this is the first time that it runs this image. So for the first time, it installs these extensions that I need. The next time that I'm going to connect inside that container, those extensions will be already there. And if I check who am I, you will see that already uses the AmiDev user. Configuration for doing that is already on my repository under these images, and there is a guide how to have those extensions automatically installed, and that, as well as the how to use a specific user for the application and the development environment. So if I go here, you will see that I have the code that we use for this project. Let's say, let's open this one. And if I go, for example, here, I can see some information and already connect to this include file. You will see the path here. Because this is something that IntelliSense does. And the defines are already working, that's fine. And if I would like, I'm using here the task runner, the extension that I mentioned earlier. And if I click to build that code, it uses the make file We see here exactly what it does. And the make file creates all the files that we need and compiles the code. And we have here the again, the executable. If I want to do it for OS4, for example, I can attach the other container that has to be the VBCC for PowerPC for OS4. And we can install it and we can compile it for OS4 as well. And you will see that if we go here, we are inside that folder, the code. If we do an ls/la code plus igame, you will see that executable file is already here. So the host machine and the container, the Docker container, communicate and share these folders. And we have, you can see here as well that the permissions are as I would like to be, and everything is ready. So here for the OS4, you will see that we see here the extension. So because of these containers share the same folder, all the containers can see the same code. So if I would like to build it for AmigaOS 4, the build file, that's fine. And in a few seconds, we are going to have the executable. Also have in mind that if we open here the code, you will see that now it recognizes that we are in OS 4, AmigaOS 4, and this is enabled, and we can link to that as well. So, the compiling finished, and we have the executable as well for OS 4. And let's have a look on Apignosis. It's an application that I created because of my need to read the Autodoc file on any of my machines. It runs on Windows, Linux, and Mac OS. And it passes the Autodocs on the fly and shows a list of the methods. And you can have a look on the documentation. Let's have a look on that. This is the application. It's pretty simple. You can click on the Autodoc here and the method that you would like to see and have it there and read it. And also, if you want to change to another Autodoc folder, you select here the Autodoc folder, and it passes all the files here, lists all the files here, and while you click on them, they are parsed, and you can do the code. Apignosis can be found on this URL on my Bitbucket. I hope this is going to be useful for you as well. Let's pass to another topic right now that has to do with the development and the deployment of our code and how Docker can be used on that. Usually, when we create an application, we plan a future or fix a problem on our application, and we develop that on our machine and test it on our machine and do a manual release to an FTP server or a website or wherever we want or even on OS4 depot or something like that. And after that, we communicate with the people to have to see what problems they have, or if it works well for them, or they need some enhancement. And after that, we go again and we do all this cycle. That's fine if we are the only developers on the project, but it has some flaws if we work on teams. And usually the projects that uh, lately we have to develop require more people to work on them, and require teams to work on them. Let's say the fine work that the people are doing with the Odyssey browser. Uh, it's for sure work that needs more than one person to work on that. And we see more and more projects require teams. So as we require more people to work on these projects, there is something that we have to have in mind, and there are processes that we have to introduce in our development process. And there is the continuous integration and the continuous delivery process that aims actually to build and test software that we build inside the team. Every time that we commit something in our repositories, on our version control repository, and we have to test them all the time, that we are as sure as we can that they are ready for deployment. Software that helps us for that are Drone, Jenkins, Title CI, and many others out there. Jenkins is the most known project for this, but I like to use on my personal project the Drone, because I feel that it's much more simple. So, and I will show you what I mean later in demos. So what is CI? What is continuous integration? Continuous integration is the practice of when we have a team of developers that work on the same project, and they commit all the time work they done, or small part of code, and they can do it many times during the day, for example. And we need this to be tested. Continuous delivery, on the other side, is it comes after the continuous integration. It's the test that we do in our software, and we are told that we are going to be really sure that they are ready to be released. For example, if someone makes some change on the code, is this code actually compiled? And if this code is compiled just fine on, let's say, an O30 for an O30 CPU, does it compile just fine for O40? Does it compile just fine for PPC for OS4? Instead of someone to go and make the compile on for every single system, we can automate this process and do the compiles. We can use specific processes to do all the compiles at once, someone as well as when someone commits some code. And that can be done with a pipeline in here for draw. There is a file that I created for the iGame. This creates a pipeline that uses Docker. It has the job of it is to compile a game for different CPUs. You will see that there are a couple of steps, a few steps actually, that have specific names that describe what the job needs, what each step does. And for example, this step has compiled for M68 68,000 CPUs, and pulls here. You will see that it pulls the same containers that we used, the same images for Docker images that we used earlier for the development. So the same images that we use, we created and used for for developing the actual code can be used for the compiling as we do it locally, also on the drone server. So what it does actually is gets in specific folder that has the repository clone and run this command. This is done for every CPU, as you see, and for OS4 and for the Morphos version. So it compiles this pipeline compiles the code on every CPU that we define here using the VBCC compiler. And when this happens, actually it happens whenever we push something in the branch named develop, which is the development branch that we use, and or whenever we create a pull request. So whenever a member of this team that develops things for the iGame project, whenever it creates a pull request, this pipeline runs. This is triggered by the GitHub repository to the drone server that we have and runs all these commands at once. This might take around 1.5 minutes, which is much faster if we were going to do it by hand. And have that in mind that every time that someone creates a pull request, that is happening, which gives us the feedback that this pull request compiles just fine. Let's check right now. Let's do the code review if we want, but at least it works just fine. So we can do that in our system. Let's see a demo for that. Actually, I have here. This is the environment where we see the drone from the drone server. And these are all the works that we did whenever someone developed something or created a pull request. Let's see, for example, here, this is a pull request, open pull request 21 for the develop branch. And as you can see here, as soon as we created that pull request, these steps run as we described in that file with the compiling of each CPU. And here we can see if something breaks or not. If it breaks, this step is going to be read and the process will stop. And we are going to get instantly that information that something is breaking. But here it is everything just fine. And also if we merge to the develop, like here, everything is running as it should. Continuous deployment is the process that we use to automatically deploy the code that we create. And this can be done whenever we want. If we would like to do it whenever we merge on the master branch, we can do it like that. Or I prefer to do it on the tag creation. So I create a tag, and whenever I create a tag, the compiles are happening, and I can deploy it to the GitHub, for example, or even on OS4 depot or Aminet automatically, since all the tests are passed. For example, this project is this code is for the drone CI, and this describes how the new images that I create, the new versions of the images that I create for Docker for Amiga VBCC are deployed into the Docker Hub repository. So whenever I create a new code, this uses the specific image from plugins Docker. It's a Docker image from drone, created from drone people, and this creates this it creates an image that will upload in this repo. This repo is on Docker Hub, and create those. It will use the tag that I will set and add this info, this PPC suffix, and it will deploy them to the Docker Hub using that username and that password. As you can see, uh, since this file, let me show you this file here on my repository. Since this file is here inside the GitHub, it would be stupid to have my username and my password in this code. So for security reasons, you can add your passwords inside the drone, and they are stored in a secure way, and you can use them like that inside your code. And as soon as I make any change on this image, they are developed on my drone server, and they are pushed, sorry, pushed to the Docker Hub repository. And the event when this is triggered is exactly that, when I create a tag. We can see that here. I go my repository. For example, here I created a tag, and that clones the code from the repo, created the base image, the PPC image, the Morphos image, and the image for the 68K, and did the build of the image of the steps here. And as soon as this was successful, it started and pushed that into the Docker Hub repository so that anyone can download and use it. So this process, if you see, it takes less than 2 minutes, and it's fully automated. Another project of mine is the AIO stream that is a few Python scripts that I have in package that help people to stream video from different online services. And whenever I create a tag, my process here is to create this package with all the scripts. So as you can see, it is pretty simple Bash coding here, where I create a release folder, and I move all these files in there, and I use the tag that I created to put a version on the name of the folder, and I use the LHA to create the LHA archive of this folder, the AIO streams folder. And as soon as I do that, I push that folder, that file, the LHA file, to the GitHub as a new release. And I use an API key for that for GitHub. And as well, I push this file to the Aminet using FTP. So use this image, this Docker image, that helps me to do FTP work, and I use these parameters to push that file using FTP to the Aminet FTP, and as well as in OS for depot. So this process, whenever I create a tag for this project, the file is deployed to GitHub, to Aminet, and OS for depot as well. Let me see. Yeah, I have that here. I created a tag on this step, and here I prepare the Aminet release, and here I upload the Aminet files to the FTP of Aminet. So I have to upload the LHA file and the README file for the Aminet. And the same happens to the OS4 depot. Have in mind that OS4 depot uses a passphrase, as you can see here, which on my script, at this point, I go and add it on the text that I sent, on the README file that I sent to OS4 depot, on the fly, on this process. And that also is stored securely inside the drone. So as I am finalizing my presentation here, what I would like you to remember from this presentation. Actually, I would like you to remember that with Docker, Docker gives us flexibility to use any compiler that we want really fast without changing anything on our host machine. Actually, we download those Docker virtual machines on our machine, and we can use them as we want to compile our product, our application. We can use them as well on automation, as we saw for continuous integration and continuous deployment. And we can use them for collaboration because these processes are extremely useful for working in teams. And all this gives us more free time. And as you know, more free time means more beer, right? So that was my presentation. You can find this presentation on this URL, and you can contact me on my email, volkero@gmail.com, for any questions or any help that you might need. And you can find me at Twitter at Sokianos. Thank you for watching this presentation. I hope you find it useful, and I hope to see soon your implementations based on Docker and give us cool new applications. Take care and